everyone. In this video, we will be simplifying rational expression, and this is the first part. By definition, rational expression is in a form of a fraction in which the numerator and the denominator are polynomial expressions. Now let's take these first two examples right here. So we're supposed to simplify y to the fourth over y to the fourth. We can actually have multiple methods of simplifying this, but I'm going to show you some few methods today. So what are we going to do first is we are going to write this all out. We're going to expand it. Y to the fourth means there are 4 y's. So I'm just going to write 4 y's right here. Okay, so I had 4 y's on the numerator and 4 y's in the denominator since it is raised to the power 4. Now, what are we going to do next here is that we remember the division by itself property. This property tells us that if we divide a number by a number itself, then the quotient is 1. So we can go ahead and label this since this is a y and this is a y. This is actually equal to 1. So I can go ahead and write a giant 1 on here. This means that this is equal to 1. And these other 3 here are also equal to 1. So I'm just going to go ahead and write that up here. Okay, so 1 times 1 times 1 times 1 would be equal to 1. So pretty much the value for y to the fourth over y to the fourth is 1. Now I will show you a different way of doing this where we cross them out. So we can go ahead and write that also this way. So we have 4 y's. Okay, so we can cross out, partner up the numerator and the denominator, and we can cross them out. We can cross these 2 out, we can cross these 2 out, and we can cross these 2 out. Now, please be careful on this because others are going to think that the answer to this is 0 because they're going to say that, oh, nothing is left over, so that means the answer here is 0. Now, please remember, we cancel them out because we were using the division by itself property, which states that if we divide a number by a number itself, the quotient is 1. So pretty much this is equal to 1. So if nothing is left in there, that is equal to 1 and not 0. Okay, so let's move on to the next one right here. So we have x over x times 7 over x and 2x over x. Just by looking at this, we can go ahead and just rewrite this down here. Okay, so we can see that there are numbers on the numerator or variable in the numerator and a variable on the denominator are the same. So that means it is equal to 1. So we can go ahead and say that this x over x is actually 1. And then this 2x over 2x is also 1. So we can go ahead and label 1 on that. So we can go ahead and say that 1 times 7 over x times 1 is actually equal to, that's going to be 7 over x. So I'm going to write that down here. So that 7 over x is the product of this. Now the other way to do this is we go ahead and write it out. We can cross this out since they are the same. Numerator and denominator are the same. We can cross this out. So we are still left with 7 over x. Now notice the difference between these two. Now others are going to say that, oh, this is pretty straightforward. The answer is 7 over x. So there's no problem to it since everything is not crossed out. But in cases where everything is crossed out, that is equal to 1. So pretty much we crossed out these two, we crossed out these two, so the leftover is 7 over x, and that's how we got over here. At this time, I would encourage you to pause this video and try this problem out on your own, and when you're done, unpause it and check your answer. Okay, so we're gonna go over this problem here. So I'm just gonna show the work down here. Okay, so the leftover would be 4 m's. So then I can go ahead and write this up here. This is m to the power 4. These two have been labeled as 1 here based on the division by itself property. If we divide a number by a number itself, the quotient is 1. So these two would be 1 and these two would be 1. So we're left with m to the 4th. The other way to do this is we can write it all out. So that would be... Okay, so what I did here was m squared times m to the 4th is pretty much the same thing as m to the 6th. And then we have an m squared at the bottom. The reason why I split this m squared out of the m to the 6 because I wanted to make sure that these two are 1s. Although you can also rewrite it. You can write them all out. That should be fine too. But this is the other way to do it. So you can see that this m squared over m squared is actually 1. So then we are left with m to the 4th. Now let's move on to the next one right here. So this problem right here, we can multiply them across. We can go ahead and say that 8 times y is 8y, and then 2 times y is 2y. So then we can see that this can be expanded. The 8 here can be expanded as 2 times 2 times 2. So 2 times 2 is 4 times 2 is 8, and then we have the y. And then 2y, I'm just going to write 2 and a y right there. We remember the division by itself property. If we divide a number by a number itself, then the quotient is 1. So this one right here is actually 1. And then this 2y's right here would also be equal to 1. So that is 2 times 2 times 1 times 1 is actually 4. So I can go ahead and write 4 up here. Or the other way that we can do this, we can just cross them out. So that would be 8y over 2y. So I can cross out the y and y. And then again, we have 8 is divisible by 2. There's 4 2's in 8. And then there's 1 2 in 2. And so we got the leftover of 4. Again, when we cross this out, it doesn't come out 0. But instead, we use the division by itself property, which states that if we divide a number by the number itself, then the quotient is 1. So the quotient here is 1 and not 0. Did you get the same answer as this 2 right here? Good. Perfect. Now let's move on to the next examples right here. So we're going to take these 2 right here. So first, we're going to rewrite it. Okay, so as you can see here, both of these are the same. We use the division by itself property, which states that if we divide a number by a number itself, then the quotient is 1. So this becomes a 1. So I can go ahead and label 1 to this. So 1 times this would come out just this expression right here. So this would be equal to k minus 3 over k plus 3. Again, the other way to do this is just to cross them out. So I'm just going to rewrite it. So we can cross out the k plus 7 and k plus 7. And again, we remember that this is not 0. We are using the division by itself property, which states that if we divide a number by a number itself, the quotient is 1. So this becomes 1. So pretty much these two are just the same. So instead of writing the giant 1 right here, we can just go ahead and cross them out. But then again, we remember that it is 1. And so the answer would be k minus 3k plus 3. Now let's move on to the next example right here. Okay, so I expanded the x plus 5 to the power 3. So we have 3 groups of them. And then we remember the division by itself property. If we divide a number by a number itself, the quotient is 1. So these two would actually be 1 right here. So I can label this as 1 right here. And then the rest are just good. But this one here, we can still simplify this. So negative 8 divided by 4. Or we can go ahead and say that there are 2 4's in 8, so that's negative 2. And then there's 1 4 in 4, so we can go ahead and say that's 1. So the leftover here would be negative 2 times x plus 5. And then there are 2 groups of them. So we go ahead and that is raised to the power 2. We can actually use the other way by canceling them out. So we can use this one right here. So that would be negative. I'm just going to rewrite it. So we still come up with the same answer. So this one's right here would be the other way of doing it. It doesn't matter which way you would want to use, but I'm just showing you that when you cross out, it's actually 1 right there and it's not 0. At this time, I would encourage you to pause this video and try these two problems out on your own. And when you're done, unpause it and check your answer. Okay, so we go over the problem here. So I'm just going to rewrite this and show the work down here. Okay, so the answer here is 1 because I actually switched this around so that they can be on top of each other. So we remember the division by itself property, which states that if we divide a number by a number itself, then the quotient is 1. So since this numerator and this denominator are the same, then this is equal to 1. So 1 times 1 is 1. Or we can cancel them out. So that would be okay, so this is where problems would come in. Others are going to think like, oh, nothing is left here, so this should be 0. So that's why I'm showing you this giant one right here. It's telling us that when we cancel them, we are using the division by itself property, which states that if we divide a number by the number itself, then the quotient is 1. So this is 1 and this is 1. And I've shown that on this work on the left. Now let's move on to the next one right here. We can actually expand this to be so what I did was I split this into 2 parts so that if I multiply 1 times y plus 5, it's just y plus 5 on the numerator. And then these two together are placed next to each other. So then we can go ahead and say that this is again a giant 1. So this is 1 right here. So then we can go ahead and say that the answer to this would be this part right here. So that is 1 over 3y minus 2. Again, please remember that these two becomes a 1 based on the division by itself property. If we divide a number by the number itself, then the quotient is 1. And so, or you can cross them out, but remember, whenever we cross out, we are actually using the division by itself property. It is not 0, but instead it is 1. Again, that's division by itself property. Did you get the same answers as these two right here? Good. Perfect. If you find this video helpful, hit like and subscribe for more math videos. See ya!